In this tutorial, we're going to add the ability for a game to track data persistence between scenes, as well as save and load that data with the save game file. Hi, my name is Michael, and welcome to my 2D action and adventure RPG tutorial series. We are learning how to build a top-down 2D game that features action, adventure, and RPG mechanics all in Godot 4 using GDScript. So in our last video, we created these treasure chest scenes, and they work pretty good so far. The player can open them, and obviously they add items to our inventory. But the issue with where we left off is that they're not persistent. So as you can see, when we leave the scene and come back, they are back to their closed state. And, you know, for some things that's probably okay, but for these chests and for a game like this, we want them to be able to remember if they've been opened. And not only if we leave the scene and come back, but also if we load our game, like if we save the game and then load it, we want them to be able to revert to whatever state we saved it at. And so that's what we're going to tackle today. We're going to create a simple node that we can add to these that's going to help track it, and it's going to tie into our save game manager that we built in previous tutorials. And so it'll be persistent during a game session as well as between save games. So to begin, I'm going to create this node that I mentioned, this scene, inside of our general nodes. So we created this general nodes folder again in a previous tutorial where we added our hit and hurt boxes. So let's create a new folder within this one, and I'm going to call this Persistent Data Helper. Yeah, if you want a shorter name, feel free. I just wanted the name to make sense, but it's kind of long. I'm going to create a new scene in here, and I'll call it the same thing, but a little bit different. I like to do my scenes in all lowercase. So persistent data, and actually I'm going to rename the parent folder. I decided I want to call it handler instead of helper, so I'll call it handler. Okay, let's just go over here, rename this. Hopefully that doesn't cause any issues. Occasionally that does if you rename a folder when you're editing a scene. We're going to need a script for this as well, so let's create that script. We'll call it the same thing. And I did that twice and I still misspelled it. So fix that spelling. And I'm going to go ahead and put this script on our persistent data handler. I'm going to take this scene and I'm going to change the type from a node 2D to just a regular node, so we don't really need anything special. And I'll just set up the class here. Okay, so we've got a persistent data handler. It extends node. We've got a scene, and we actually don't need anything in the scene. It's just going to be an empty node whose sole purpose is to make it easy to reuse and drop it into other scenes that will need this persistent kind of behavior in the future. And today we're just going to add it to our treasure chest, but you could add it to things like switches or doors, or, you know, even quest related things, like maybe an NPC only appears if a value is set to true or false, right? And so before we get into the code here, essentially what this persistent data handler class is going to do is it's going to very simply have a value of true or false. It will emit a signal so that any parent node that needs to listen to or react to the change of that value can do so. And it's going to have methods to be able to set and get that value from our save game data. So we'll set that up. I'm going to open our global save manager because this is where we're going to save the data. So in our previous save game tutorials, we created this dictionary, and we've got this persistence array. And what we're going to do is we're going to push items into this array, and it's going to be things like, I'm going to simplify this, but it'll be something like level 01 / treasure chest 01 / open. Okay. And we won't have like a closed. Rather, we'll just infer based on the presence of this open Boolean that it's true. And if it doesn't exist, then it's false. So if there was 3 treasure chests on one scene, and when we look, we only see that the treasure chest 2 has an open string saved, then we'll just know that the other ones are closed. Now, the reason I've decided to do it this way is because it fits well with the JSON data structure that we're saving. There are other ways you could save this. You could save them as actual Booleans and things like that. but it's also really kind of important that we have a very distinct identifier for each item that needs persistence. And it needs to extend beyond the item name, because, if we only tracked something like this, like what if we said treasure chest 2, and then, like if this was an object in a sub dictionary instead of just an array of strings, right? We could say name equals treasure chest 2, and then we could say is open equals true, something like that, right? That gives us the exact same data with more code, with slightly more structure to this object. So this Boolean isn't necessarily needed, but also there's an inherent problem with storing a string that just has the name of the item, and that's that you might have lots of treasure chests in the game that are called treasure chest 02, because, if we look at our scene, every time we drop in a treasure chest, it just is going to, right, it's going to be named in the same fashion, unless we go through and rename them. And then there's no way for us to know for sure if we've chosen a truly unique name, and that makes it difficult. And that's why I want to do something like just put the level name and then the node name. If we put a full path to this node, then that should be unique in every circumstance. And this is oversimplified, and you'll see as we write the code what exactly that's going to look like and how we're going to ensure that the identifier that we use for that item is truly unique. So let's go ahead and jump back to our PersistentDataHandler class that we've created, which is applied to this scene. And let's set it up. So as I mentioned, we're going to want a signal. And this signal is just simply going to indicate to whatever's listening when data was loaded, so that we could respond to that. I guess we don't need the parentheses there. And then we'll also have a variable that we'll just call value, and it's a Boolean, which will be false by default. And let's set up some of our functions and methods that we'll need. So we'll use the ready function, and we'll have a function called setValue, okay, which, as it says on the tin, that's where we're going to set the value when it changes. We're going to want a function also to get the value. Okay, we've got setValue, getValue, and I'm going to create one more in here. I'm going to just call this function getName. And this can return a string. And okay, I'm actually going to give this, I want to make this private, and that underscore is just going to indicate to me that this is kind of a private function that I only want to use within the node. And let's build this one first, because this is how we get that unique identifier that I was mentioning. So what we'll do is we'll say get tree dot current scene. Okay, so this thing is going to look, whenever we call this get name, this node is going to say, okay, what's the current root scene? And the way we've built this game, it's always the way our level manager works, it's always the level that we load, right? But it could be anything, but it's going to get that scene. So it's going to say, if we're looking at level 1, then it's going to find this scene, okay? And then we're going to do this. We're going to say scene file path. So this is actually the resource path to our file. So what that looks like, and I'll just put this in a comment above, is that's going to look like, that string is going to look something like this: resource : levels / area 01 / 01.tscn. I think that's how I have my thing structured. So that's what the string is going to be with just this bit of code. And then in order to make this work full circle, we're going to add to the string. I'm going to add a / so it keeps kind of that same structure so it's easy to read. And then I'm going to say get parent name, get parent. So that'll get the parent node dot name. Okay, so that's going to return whatever the parent node of this item is. We'll add one more /, and then we're going to add the name of this node. Okay, so which right now is called PersistentDataHandler. You'll see how this works in just a second and how we're going to utilize this. So by the time that string gets built, it's going to look something like, maybe this is the treasure chest, right? And then there's going to be another /, and this is called PersistentDataHandler. I really don't like how this is spelled out here either. I'm going to just change that to be all PersistentDataHandler. Nice. I like that better. So then when we do the name of this node, it's going to look like this. So this get name is going to return something like that, a string that looks something like that. So let's go ahead and in our ready, let's just print this so that we can kind of test this get name function and see how it works. So we'll do get name and we'll just call it good. So I'm going to go ahead and save this script. We've obviously got our persistent data handler, but let's open our treasure chest scene and let's add one of these persistent data handlers to this scene. So now all other treasure chests are going to have this persistent data handler. And actually, I'm going to rename this persistent data handler to persistent data is open. Okay, because that's the specific data we want to track with this one. And in fact, you could even just rename this node is open. The only downside to doing this is you lose that visual label or reference to what kind of node this is. So, do what you want. I'm actually going to leave it as is open right now because it'll make this script make a little bit more sense. So theoretically, since we've got this in on our treasure chests, we should see a debug for every treasure chest in our scene. So here you can see in the output, right, those 3 strings. And so we've got levels, area 1, O1 scene / treasure chest is open / treasure chest 2 is open. So by naming it this way, when we save this string into our save data or write that to our persistence array, we're just going to know, oh, okay, that treasure chest is open, right? That's how we'll determine it. And then anything that isn't open is closed. So hopefully that kind of makes sense. And in this simple fashion, we'll be able to track just a simple Boolean variable. If you wanted this value or this to track very specific things like a specific string or a count or numbers, you could do that. And our array could contain more than just the string name. And there's nothing wrong with doing that. You're welcome to do so. I just thought it would be nice to make something clean and easy to use. It's kind of why I've built it this way. So let's go ahead and finish out our script and then we'll test it out. So we'll do get value in our ready function because we always want to get the value when this thing loads, right? We always want to figure out if it's been open or not. And that means like when the scene loads, if a treasure chest is in that scene, it's as soon as that treasure chest loads, this node is going to load and it's going to check its value. So let's build the get value function. Actually, what we need to do is go to our global SaveManager and we need to build some functions that we can utilize within here to get and set that data as well. So let's just, in the bottom of this script, let's add 2 new functions. Okay, so we're going to have a function called add persistent value. And this is going to have one argument of value, which is a string. Doesn't need to return anything. And then we'll have another function called check persistent value, because we don't need to technically load it. The difference between loading, in my mind at this moment, is loading a file from disk, and checking being just checking the current save game data that we have. So for this, we would need to pass in that same string. Okay, check persistent value. So we're going to check if it exists, right? Because if it does, then that means it's open or whatever. Let's do our check persistent value first. So we'll say P equals, and I'm doing P as my persistent item array. So we're going to go to our current save dot persistence. We're just going to load this, get a reference to it as an array. I don't know if that's entirely necessary, but I feel like when I tested this, I must have had a small issue that this helped alleviate. And then what we can do in the array, and this is probably it, is now that we know that it's an array, we can check. There's this method that belongs to arrays called has, and we can look at the documentation for that. Has returns true if the array contains the given value. And obviously it returns false if it doesn't. So what we can just do is just say, does our persistence array have the value we passed in, right? True or false, okay? And then for our add persistent value, we'll go if check persistent value is false, meaning we don't find, so let's say we're going to save a string that just says apple. If it's already in the array, we don't need to save it. Otherwise we'll get 2 of them. But if it's not in the array, Then we'll go current save dot persistence dot append, and then we'll just pass in the value. Okay, so we'll only save the value if it doesn't already exist. Oh, I have a problem here. I didn't make my check persistent value return anything. I told it to return void, but we actually want it to return a Boolean. There we go. Okay, so this is all we need to be able to do this. So as we're adding values, let's look at our persistent handler. When we call the set value, then we want to add it to our save game, which is just going to add it to this current save object. And we're not actually going to save it at this point. You could do this one of two ways. You could either save this every time you add a value, or you could save it when the player chooses to save the game, right? And the difference being, if you save it every time, if the player opens a treasure chest, then it saves that. And then even if they die and come back to that level, the treasure chest is open. Whereas the way we are building it, if the player comes and opens a chest and dies before saving the game, when they reload the game, the treasure chest is going to be closed again. It's up to you how you handle that, right? It's really a design decision for your game. But we're just going to add it to that array. And simply by adding it to the current save, it will add the persistence we need between levels without even saving a game. But then we already have a save game function. And even though we're not calling anything specific, since that value is inside our current save, and we're saving our current save right here, that data is going to get saved. We don't have to do anything extra. Okay. So let's go to our persistent data handler, and let's just hook up what we need to on these functions. So set value is going to call the SaveManager. Add persistent. Don't have a code completion just yet for whatever reason. Add persistent value, and then we'll just call the get name. Okay, so we'll get this name. That we're going to check. And the load is going, or the get value is going to be similar. We're going to say value equals SaveManager.check persistent value. And again, we are going to call the get name here to get that string. And the only difference is here we also want to emit data loaded.emit and value. So actually, yeah, with our signal here, we'll just say that it expects a value. Okay. So let's go ahead and test this. Well, actually, hold on. We need to do just a little bit more, because the script is ready for this persistence item, but our treasure chest isn't utilizing it. So let's hook up the treasure chest. Let's go in here to treasure chest, open the script, and in our onReady, let's just get a reference to, oops, I didn't mean to grab the treasure chest itself, but we want this is open persistence data handler. We're getting an error because we already have an is open value here. So let's just call this is open data. That'll resolve that warning, that issue. Okay, now that we have a reference to our is open data, let's come here to our ready function, and let's get the is open data, and we've got that signal data loaded. Let's connect to it, and we'll create a function here that we're going to call set chest state. Okay. And then we'll call that function as well. We need to call this function when it starts and anytime that signal is emitted. And this function is going to it's going to be pretty simple. Set chest state. We'll go is open. First, we need to get our is open value, and that's going to equal our is open data dot value. And then we also need to, if it's open, right? So if is open is true, then we're going to grab our animation player and play the opened animation, opened past tense, not the open chest, but opened. Else, we will get the animation player and play closed. Got a little typo there on my play. Okay, so we have a set chest state. I think this is mostly ready, but let's go back to our persistent data handler. I want to make sure we're not actually emitting a value. We don't actually need to do that the way we wrote that. So just go back to your code, make sure you're just calling emit, and then your signal, it doesn't need any parentheses on it. Okay, just a signal just like that. So once your code matches that, we should be able to test this out. So I'm going to just come up to one of these chests and open it. Okay. Let's leave the scene and come back. No worky. Okay, let's take a peek and see if we can figure out why it's not working. And I have a hunch that in our open chest, we didn't call the function we need to. So treasure chest, let's see. On the player interact, just somewhere right about here. Yeah, we need to go to our isOpenData and just call the set value function. Okay, let's try that again. Okay, ready? Open the middle one. If we leave and come back, ta-da, it's open. And in fact, so let's go ahead and do this. Let's save our game. I'm going to just leave and come back just for fun. Okay, they're open. Load. And so you notice that the save and load is working. And those are already open. So there's one last thing we can work on and we can try and fix. And that's that you notice the chests, when we see them for just a second, they're closed and then they pop open. Now, the reason why that's happening is because in our scene transition, we actually pause the game logic while that fade transition happens. And so the chests aren't running their script until the end of that transition. And so what we can do is we could just come over, we could go to our treasure chest scene, and we could go down to process here and change the mode from inherit to always. This should resolve that issue. So let's just try this. Let's open a chest, leave and come back. Yeah, there we go. That's instant. Same with when we load it. It's instant. Okay. Now, if there were issues with that, I mean, I don't know if this is the best way to want to always handle it. In fact, well, I think it kind of is, but maybe what you might want to do, if you run into errors where the treasure chest, is doing stuff when it shouldn't, you could always come in here and after you set the chest state, maybe you set the process mode back to inherit so that it's pausable again. I don't know, it's up to you. But for now, I think I'm going to leave it. So there we go. We've managed to pretty quickly update our treasure chests to remember their state and to have that kind of persistent data tracking. And you could take that persistent data handler node that we've built and apply it to other things like I've mentioned, like maybe you want these plants after you chop them down, it remembers, whatever. You could add it to anything. Just remember to put the appropriate code in each of those data handlers and you can do all sorts of things with it. All right, well, thanks for watching. I hope you guys have learned something new yet again. Please comment below and tell me if there's anything that didn't make sense, if you have questions or other things that you want to learn how to do. And as always, I really appreciate any subscribes and likes. Those help my channel grow and attract other people to view these videos. And as always, we'll see you next time.